Good afternoon, guys. I will try to show you how to solve the 2 circuits that I gave you. So every time you look at a circuit, guys, you must look at two things. Look at your current. If current splits, it tells you that your resistors are in parallel. If current does not split, it tells you that those resistors are in series. So we can start by solving these three. Because if you look at this, current comes towards these three and it splits 3 times. Therefore, it's telling us that these three resistors are parallel. Then to solve a parallel combination, just use this equation. R parallel is equal to open brackets, and then you write all the three values as fractions. So 1 over 12 plus 1 over 6 plus 1 over 4, everything to the exponent -1. If you punch this in your calculator, your answer will be 2 ohms. Then next step, if you don't see what will happen in your circuit, try to redraw your circuit, because now if I can redraw this circuit, it will be something like this. We still have the 3 ohm resistor there, and then we can replace these 3 resistors by one value, which is equal to 2 ohms. Then we still have our 20 ohm resistor at the bottom, then the 5 ohm resistor, then we still have our battery. Okay, so next, now we need to look at this circuit. Now we can clearly see that if I look at my current from this position, current flows through this 3 ohm resistor and the 2 ohm resistor here. Current between these two resistors does not split, so therefore it's telling us that these two resistors are in series. So next step will be to say that was R parallel 1. R series 1 is equal to 3 plus 2, which will give us 5 ohms. Okay. Then you go back to your circuit. So now next step, we can say we have added these two resistors, so we no longer have these two resistors in our circuit now. So we can replace these two resistors by one value, which is equal to 5 ohms, and then at the bottom we still have the 20 ohms that we had, and then the 5 ohms there. Okay. So now if you look at your current now from your battery source, it goes here, it splits. Okay, so we can see that now it's splitting 2 times, splitting twice, so therefore only these two resistors are in parallel. We can't add the 5 ohm resistor. And the reason I did not add this 5 ohm resistor to that series combination, it's because when current flows get to this point, it combines with the one that comes from the bottom. So by the time it gets to 5, it's the combination of those two. Okay. So next step, then we will say R parallel 2 is equal to 1 over 5 plus 1 over 20, everything to the power -1 equal to, answer for this will be equal to 4 ohms. Okay. Then the reason I'm using this formula, it's because most of you forgot to flip the fraction after adding your fractions, forgot to flip your answer. But if you use that -1, your calculator will split it for you. Okay. Then next step, we'll say now we no longer have these two resistors now, because we have combined them, two resistors. So I can replace now those two resistors by one value, which is equal to 4 ohms. Then I will still have my 5 ohm resistor there, then your battery, which is 24 volts. Okay. So then your last step then will be to say, therefore the total resistance of this circuit is equal to the 4 ohm that you've calculated plus 5 ohms, which will give us 9 ohms. Okay. So that was the first question. We had to calculate RT. The second question, we were supposed to calculate I total. So now I total, we use Ohm's law. I will always be equal to I is equal to V over R. Then if I'm looking for IT, I need to divide by RT. Then this will be equal to, the voltage is 24 volts divided by 9 ohms. I think this was 2,67 amps, but you can verify it using your calculator, because I'm not sure about that value. Okay. And then the third question, that's where we struggled, majority of you. Now, the third question, they want you to calculate the current that flows there. It was labeled I1. Okay. So now we know that we want this current. Can I use the 24 volts at the bottom? The answer is no, because 24 volts is across the whole circuit, not across the resistors where this current flows. So always, guys, if you want to calculate current somewhere in your circuit, first calculate the volt drop. What's going to be easier for you then, if you are redrawing the circuit, then you will know which value to multiply with, because current flowing here, my IT is flowing here, which is 2,67. It's flowing there, okay? But if you look at it, follow that current, it flows until it gets to this point. When it gets to this point, the current splits. So current flowing there is less than this 2,67. But if you come back to the circuit that we have redrawn, current flows towards the 4 ohm resistor. It can't split because I only have one resistor. So therefore, to calculate the voltage, I will say V parallel is equal to I times R. How much current flows through that resistor then is equal to 2,67 times. How much resistance is there? 4 ohms. I can't remember now the value. 10, I think that was, let me confirm the value. How much will be that current? Okay, so the value of this voltage then will be 10,67 volts. Okay, then if we come back to our circuit, remember before the circuit had this 4 ohm resistor, maybe let's redraw that first circuit that was here. That circuit had 5 ohms this side. Then at the bottom it had 20 ohms. Then through that side to that 5 ohm resistor as well, then your voltage. So what we are looking for now is the current that flows there. Then what we must know is that in parallel the voltage remains the same, meaning if we calculated and got 10,67 across the parallel combination, it means 10,7 this side and 0.67 on the bottom. So then I can easily say my I1 is equal to V over R equal to 10,67 divided. Okay, some of you made just a careless error of dividing by 3. You can't divide by 3 only because this current flows through the 3 ohm resistor and it also continues to the other part of the circuit. And the value for that combination was 2. So therefore this current flows through the 3 ohm resistor and the total of this section, which is equal to 2. That's why we have to divide by 5. Then the answer will be, I think, okay, let me first confirm it. Okay, so the answer for this current is 2,13 amps. Or another method that you can use, but what you must be careful for in using this method is called, we use a method called current divider. Okay, what is important about this is that it's only used when you have 2 resistors in parallel. Meaning we can apply that law in this case because I only have a 5 ohm and a 20 ohm resistor that are in parallel. Okay, so the law is, if I'm looking for I1, the formula is R2 over R1 plus R2 times I total. What does that mean? It means if you are looking for I1, then between the 2 resistors which are in parallel, on your numerator you must have the value of the resistor opposite to the current that you are looking for. If you look at this one, I'm looking for current through I1, meaning the opposite resistance is equal to 20. So my numerator then will be 20 divided by R1 is the one where current flows, which is 5 plus 20 times current, that one is I total, which we calculated somewhere, it was 2,67. 2,67. Even if you use this method, you will still get 2,13 amps. Okay. Unfortunately, I have experiencing load shedding now, so I will try to do the other circuit tomorrow. So I will try to do a circuit every day until we get it right.